Hi, and welcome to my video on extra problem number 2 on coordinate geometry. Again, the more problems you see done differently, the more you will comprehend the topics that you're doing. Number 1, find the perpendicular distance from 3, 4 to the line passing through the point 1, 0, and 6, 5. Express the distance as a radical in simplest form. Well, let's call A 3, 4. Let's call this one B and this one C. That'll keep these points straight even though it wasn't done, when the question was given, but that'll indicate what points we're looking at. Now, let's draw a grid again to get a picture. Find the perpendicular distance from 3, 4. 3. So this is the point A, which is 3, 4, to the line passing through 1, 0. X is 1, Y is 0. So that's, we'll say, is B. And C that's 3, 4, 5, 6, 6, and 5. So 5 is approximate here. So 6, 5, probably right there. So C. It says find the perpendicular distance from A to the line passing through B. Here's a line. So there's the line passing through B and C, and we want to find the distance. In math, when we find distance from a point to a line, what they mean is that even though it's not said, the distance from a point to a line is understood to be the perpendicular distance. So we're trying to find this distance coming down here from A to this line, and the perpendicular distance forms a right angle. So we got to find how we're going to find this distance. Well, we got the equation. Let's find the equation of BC. So B is, if we find the equation of each line, if we can, let's find the equation and find the two equations and solve them. And that will give us the point where they intersect, and then we can use the distance formula. So I'm going to get the equation for BC, and then we're going to say that this point here, the point of intersection, I'm going to call that another name, call it I, so we won't get confused. So let's get the equation of BC. So the slope of BC is y2 minus y1 over x2 minus x1. So that's 5 over 5. So the slope of BC is 1. And we need the equation of the lines. So y equals mx plus b. So we can either take b or c. I elected to take b. So this is x, y. Y is 0. M is 1. B is 1. 0 equals 1 plus b. So b is 0 minus 1. So b is negative 1. So the equation of BC is y equals mx plus b. And so that's m is 1. And x and b is negative 1. So the equation is y equals x minus 1. So that's the equation of the line BC. Now, if that's the equation of that line, that means that the perpendicular distance, that means the slope of AI is, because they're perpendicular, the negative reciprocal. So the slope of BC is 1, so the negative reciprocal is the negative of 1. So the reciprocal of 1 is 1, so it's negative 1. And so AI, we don't know what I is, but we do know that A is 3, 4. So we can get the equation of AI, y equals mx plus b. So a, x is 3, y is 4. So 4, slope is negative 1, x is 3. 4 equals negative 3 plus b. Negative 1 times 3 is negative 3. 4 plus 3 equals b. B equals 7. So the equation is y equals mx plus b. So the slope is negative 1. So it's the negative of x plus 7. So here's the two equations. This is the equation of BC. This is the equation of AI. So if we solve these two equations, then we'll get the point of intersection. So what I'm going to do, because this equation is solved for y, and because this equation is solved for y, I'm going to sub x minus 1 into place of y. And now we can go x plus x equals 7 plus 1. 2x is equal to 8. Divide by 2, x equals 4. And if x is 4, then we're going to put x equals 4 into, and you can pick either equation, y equals x minus 1, y equals 4 minus 1, y equals 3. So the point, so I is the point for 3. So if A is 3, 4, and I is 4, 3, we can use the distance formula to find the length of AI, the distance. And the distance formula is, this is x1, y1, x2, y2. So it's x2 minus x1 plus y2 minus y1. And I just got to mention, notice I put the x's and then the y's. You could have the y's and then the x's, makes no difference because of the plus sign. So x2 is 4 minus 3, x2 minus x1 squared. y2 is 3, y1 is 4. And that gives me 1 squared. This gives me negative 1 squared. So now 4 minus 3 is 1. 3 minus 4 is negative 1. So 1 squared is 1. Negative 1 squared is 1. So that's a root 2. So the perpendicular distance from A to this line BC, this distance is root 2. And I want it as a radical in the simplest form. You could change it to a decimal, but I want it a radical. Okay. Here's an interesting question. Find the coordinates of the center of the circle if 4, negative 7, negative 2, 1, and 6, negative 3 are on the circumference of the circle. So what I'm going to do, I'm going to label these points. Let's make this Q so we know what we're talking about. Let's make, so we'll make Q, and we'll make this P, and we'll make this one R. So again, let's draw the diagram to represent. So we want, find the coordinates of the center of the circle. These points lie on the circumference of the circle. Let's draw this first, and then we'll, so 4, negative 7, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So 4, negative 7 is right here, and we'll call it Q. And now we have P is negative 2, 1. So negative 2, 1 is right here, P. And R is 6, negative 3, 4, 5, 6, and 3, negative 3. So there's R. So these 3 points lie on the circumference of the circle. How are we going to find the center? Well, if I take a point over here, there's a point somewhere around here. As you can see, I got to draw a circle to do this. So if I take a circle and do this, that's close to it. So these are the points that lie on the circumference of the circle. So I just drew this. That means the center of the circle must be here somewhere. How do we find it? Well, there's an idea that what we call the perpendicular bisector theorem, that if I draw this chord QR and I draw this chord PR, these are two chords that's in a circle. Now this will come up again in another unit on, if you haven't already done it, it's in a unit on arcs and secants and central angles in dealing with a circle. So what happens is that I dealt with in a previous unit on congruency, but the perpendicular bisector theorem. Any point on the perpendicular bisector is equal distance. So if you take PR and find its midpoint, and then we draw a line through that midpoint, perpendicular, like that, and we take RQ and find its midpoint. So there's the midpoint of these two. This is the midpoint of this one. And we construct the perpendicular bisector of this one. So there's the perpendicular bisector of RQ, and this is the perpendicular bisector of PR. So that means that this point right here, where those two perpendicular bisector meet, is the center of the circle. And the reason is, if this is the point, then this is the radius of the circle, this is the radius of the circle, and this is the radius of the circle. So these are all radii. So this is the center. And what happens is that if a point is on the perpendicular bisector, it's equal distance from the end point to the segment. This point is on this perpendicular bisector, so it's equal distance from the end point of this segment. So that means that if you call that O as the center, OP equals OR, perpendicular bisector theorem, OR equals OQ, perpendicular bisector theorem. So that means all three of these are equal, OP, OR, OQ. So that means we have, this is the center, because these are all radii. So to do that, we're going to get the equation of the perpendicular bisectors and solve them. So here we go. So we have, let's get the perpendicular bisector of PR. So PR. So we're going to get the midpoint of PR. So the midpoint of PR, so P is -2, 1, and R is 6, -3. So the midpoint is, we add up the x's and divide by 2. -2 plus 6 is divided by 2, and 1 add on -3 divided by 2, and so that gives us 4 divided by 2 is 2, and -2 divided by 2 is -1. So this midpoint, we'll call it F. Call that midpoint F. So now we'll get the slope of PR, because the perpendicular bisector slope of the perpendicular bisector here is the negative reciprocal of the slope of PR. So the slope of PR, we have P and R here. Slope is y2 minus y1 over x2 minus x1. So that gives double negative. So that's a double negative there, the pluses. That's a -4 over 8, which is negative 1/2. So that means that the slope of the perpendicular bisector, so the perpendicular bisector of PR, the slope of the perpendicular bisector of PR is 2, because it's the negative reciprocal. And that perpendicular bisector goes through F, which is 2, negative 1. So we're going to take the slope of the perpendicular bisector, which is this one, going through F. That's the point that we don't know what this one is yet. So we'll take that info, and this is X and Y. So Y is negative 1, the slope is 2, X is 2, and we'll work that out to get the y-intercept. Negative 1 minus 4, negative 5b. So the equation of the perpendicular bisector of PR is y equals mx plus b. So y, the slope is 2, and the y-intercept is negative 5. So that's one equation. That's one perpendicular bisector. Now we'll work on getting the perpendicular bisector of the other one. So let's work on the perpendicular bisector of RQ. Perpendicular bisector of RQ. So R is 6, negative 3, and Q is 4, negative 7. So we're going to find the equation of the perpendicular bisector. So let's get the midpoint of, this is R, this is a Q, just make sure. And the midpoint is add them up and divide by 2. So 6 plus 4 over 2, negative 3 plus negative 7 over 2. 10 over 2 is 5, and negative 10 over 2 is negative 5. And we now need to get the slope of, I got to be careful now. This is the big M is midpoint, small m is slope. And so the slope is y2, negative 7, minus y1, x2, which is 4, minus x1, which is 6. Double negative is a positive. Negative 4 and 3, negative 7 and 3 is negative 4, all over negative 2. So the slope is 2. And so that means the slope of the perpendicular bisector of RQ is, that's a plus, so we make it a minus, and reciprocal of 2 over 1 is 1 over 2. So that perpendicular bisector is going through the midpoint, and you could call that midpoint G. So we call that G. So G is 5, negative 5. So we'll get the equation y equals mx plus b, because we have a slope and a point. This point is x comma y. Y is negative 5, slope is negative 1/2, x is 5, and b. So negative 5 equals 1/2 times 5 over 1 is a negative 5 over 2 plus b. And we can multiply by 2, or we can bring the 5 over. So we multiply by 2. So negative 2b is negative 5 plus 10. Negative 2b is 5 divided by negative 2. B is negative 5 over 2. I could have put the negative 5 over 2 over here and made it positive and just added up the fractions. But I've decided to multiply by 2 2 times -5, 2 times -5 over 2, 2 times b, and then move the b over and solve. So we have a slope, y equals mx plus b, and we have a y, the slope is -1/2 x, and the b is -5 over 2. So let's write that a little bit better. -1/2 x minus 5 over 2 without having the plus there. So now we have the two equations. So we'll solve this equation, should give the point of intersection. And again, both equations are equal to y, so we'll let 2x minus 5 equal 1/2 x minus 5 over 2. So again, we're solving these two equations. Because both equations are solved for y, I'm letting 2x minus 5 equal to -1/2 x minus 5. So let's multiply everything by 2 because we got a fraction. So 4x minus 10 equals -1/2 times 2 is -x. 2 times -5 over 2 is -5. So 4x plus 1 equals -5 plus 10. The x moves to the right, change the sign. 10 moves to the left, change the sign. 5x is 5. Divide by 5. X equals 1. And now we're going to sub that into, so let's take right here, x equals 1, and sub it into this equation. Y equals 2x minus 5. X is 1. 2 minus 5. So y is -3. So the point of intersection, or should I say the point of intersection, so the point is 1, -3. That's the point of intersection of the two perpendicular bisectors, but that's also the center of the circle. There's a circle with a dot in it. The center of the circle is 1, -3. Again, little different problem. Perpendicular bisector theorem that we did in congruent triangles. If this is the perpendicular bisector, just to review, if this is the perpendicular bisector of PR, then any point on this bisector, this point, if I pick this point here, that's equal distance from R and P. If I pick this point, which is the midpoint, it's equal distance from R and P. If I pick the center of the circle, it's equal distance from R and P. So that brings us to the end. If you like my video, click on the like button, click on the subscribe button if you wish. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.